Good morning, eights. So yesterday, you should have completed this investigation where you go through it, you're trying to make multiple triangles with each set of information, decide if they're congruencies. If you haven't finished that, go do it now. This must come first. It's the setup for why the things work. And if you don't do it, I don't think you'll be convinced of what we're about to talk about. So once you've finished this, now you should be with me. I'd like to go over quickly a key for it and just say, these are the things I was hoping you would see. I would not be surprised if you made some mistakes, and that's totally fine if yours is not exactly like mine. It's an investigation, so you were supposed to investigate, and if you did, you met my objective. When you investigated, if you had perfect logic and everything was good, you would have had things like this. We want side lengths of 3 centimeters, 4 centimeters, an angle of 20 degrees. I'd used physical tools to make this, so you can see my dot from the protractor, and then I connected going straight towards that dot, forms a triangle. It's good. To try to make another one, we can make lots, but they are all congruent to this triangle. So that means none of these triangles are unique, they're all the same as this, which means side angle side is a triangle congruence. The endpoints of the red side, I don't have a red side here. Anyway, it's only possible to complete this triangle in one way. If you tried it, I think you'll be convinced. Side, 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 we hit very similar things. We definitely can make a triangle given this set of information. In yesterday's video, we had an example of when we can't make a triangle and why that happens, but today we can. So we get this triangle and great. We can't make a second one. No matter how we put these things together, we can try to rearrange these sides and whatever. All triangles are congruent to this one, so side, side, side is a congruence. Next one, side, side angle or angle, side, side. We actually can make multiple triangles. When this angle is on the outside, then you have this length, whatever it has to be. I put 4 centimeters next to it, great. But this last length, 2.5 centimeters, you can see if I swing that length out like the radius of a circle, it hits here and makes an acute triangle, which is great. And then that side can swing out and make a second obtuse triangle. So what that means is given angle side side or side side angle information, it is not a triangle congruency. There are exactly 2 possible triangles, which means this can be very useful information, but not all triangles are congruent. There are 2 possibilities, so you have to be aware of that. Then angle side angle, oh, and by the way, that means when we see side side angle come up, it'll be in a different classification. Angle side angle, it's not possible to make a second triangle no matter how you draw this with the side between the angles. It ends up being a triangle congruency. So then angle, angle, side, we end up making, there are 2 possibilities where the side is outside the 45-degree angle and where the side is outside the 70-degree angle. I get 2 different triangles. So good. When I look at that though, well, that would mean in this case, it is not a triangle congruency, and that's good, that's fair. 2 triangles can be constructed based on which side we put the side we were given on, which angle we put it next to. I want to make a side note. There's a question of definitions here, and when we refine that definition, angle angle side will be a congruency, and we'll have to do that later on. For now, I just want to say, trust me, it will be a congruency, and yeah, we'll get there soon. Actually, when I think about it, we'll get here next year, but that's fine. Just know that it will be a congruency when we get there, but it's a question of definitions, and we have to change our definition to make it. The way we look at it now, it's not, and that's fine. Angle, 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 I can make a small triangle with it, or I can basically pull this side out and the angles don't change. I just get a larger triangle. That means angle, angle, angle is not a congruency. There are no side lengths, so the triangles can be larger or small as we desire. This specifically is a different type of thing, however. These triangles are not congruent, but they are something very important, and so we need to talk about that. So here's what we have so far. Triangle congruencies, if I list them all out, we have this. This last one we found is not a congruency. I've made a note, it's a question of definitions. Maybe then I should make it stand out because we haven't really resolved that yet. And it looks like it's not a congruency to us now, but that's fine. Just know that we'll refine our definitions and it will be. Good. Similarity is what angle, angle, angle gives you. Just saying if we have 3 angles the same, then I can make a small triangle or a massive triangle. And either way, the angles are the same. That's an important relationship, but it is not congruency. It's similarity, it's different. And then we have this one that's neither. The one that's neither is side, side angle or angle, side, side. We saw this is the one that we produce like this basically, or you can swing that piece out and get a second triangle out here, like this. So you end up with two possible triangles with this one, makes it not a congruency, and it's kind of easy to remember because one of the ways you can write it is ASS. It's the only cuss word in all of the triangle similarities. So the one that's a cuss word is not a congruency. But angle, angle, angle is similarity, and all the rest of these are congruencies. It's usually easier to just remember these two are in special situations, and all of the rest are congruencies. That's it. Here's a couple other things that we need to know. One is other angle relationships. One we looked at last year and probably looked at before, parallel lines with a transversal. One way I could mark these parallel lines is I could put a mark on them like that. If we have a second set of parallel lines, I would put a second set of those on them. Great, okay. So we have parallel lines, transversal coming across. The angles marked in red are congruent, and this is something that we proved and dealt with in the past, but we won't today. So just know the angles in red here and the angles in red down here are congruent, and this should be review. The one that will come up quickly is going to be alternate interior angles, which is that angle and this one. These angles are on the opposite side, on the interior of the parallel lines, opposite side of the transversal. So these relationships will come up, and they come up often. Today, the way I wanted to make them come up is to look about this. One result about triangles. Here I have a triangle, and we have a line that I drew that just happens to be parallel to this base of the triangle. So CB is parallel to this line up here. Well, then if those are parallel, then here we have alternate interior angles. So however big angle ACB is, this angle is the same. Angle, well, I'll just put D and say angle ACB is congruent to angle DAC. So just saying the two orange angles are congruent. Well, we also have alternate interior angles on this side, so I can mark them like this, saying that angle ABC is congruent to angle, I'll say E is out there, EAB, EAB. Great, so we have congruent angles. What does that mean? Well, the other thing we can see here is that, I'll just go black, I haven't used black here. These three angles up there all add to 180 degrees. What that means is, this angle here, and this angle here must also add to 180 degrees. So just saying yellow plus yellow, and I know the yellow is hard to see, and yellow have to add to 180 degrees. And what that means, if you look at those three angles there, is that those are the three angles inside of a triangle. And I know you guys already know that, but this is a proof of why it happens. The three angles inside of a triangle all have to add to 180 degrees. So you will need this relationship today for certain. You will also need these relationships today, or at least they would be useful if you knew them. So knowing those things, your assignment today is this, and I hope it's interesting because it's pretty deep. It's interesting to think about. We have triangle things. We know we can mark parallels like this. These links are congruent. Angles are marked like that. So here we have a situation. Is it possible to find these angles, W, X, Y, and Z, using those relationships we just talked about? Note, line DC and line AB are parallel to each other. Once you've decided about those and told me why or why not, then I want you to come down and look at these and decide, are these two triangles similar? And remember, similarity is the same thing as we hit back here. Angle, angle, angle produces similarity. So that'll be the last piece you'll do, and I'm probably talking too much. Thanks very much, Aids. Best of luck, and I'll talk to you soon.